Welcome to this deep dive. We're jumping straight into, well, one of the most significant tech races happening right now. A real geopolitical competition, too. We're talking about the global race for dominance in quantum technology.
Exactly. And it's not just, about future supercomputers anymore. Quantum is really starting to move from the lab into, well, into the real world. And nations are definitely seeing it as critical for national security, economic power, global standing, the works.
Absolutely. And to help us get our heads around this complex picture, we've been focusing on one key source. It's a strategic report, basically a snapshot of the global quantum race as of 2025. It really lays out who's doing what, where they're doing it, and maybe why.
Yeah, and our mission today is really to unpack what this report is telling us. We want to understand, the key players involved, the very different strategies they seem to be adopting, what milestones they've hit, and also the big challenges that are still standing in their way.
Because, as the report really underlines, these quantum technologies, they look poised to be deeply disruptive across so many areas. Cybersecurity is a big one, breaking current codes, making new unbreakable ones, but also finance, discovering new materials, optimizing logistics. It feels like a fundamental shift.
Huge implications, yeah. So we'll be looking closely at the main players the report focuses on. That's primarily the U.S., China, and the EU, their strategies, their progress. And then we'll also touch on how others, like the UK, India, Australia, are sort of carving out their own niches in this race.
Okay, let's get into it then. Let's unpack this race, starting with, well, the player the report identifies as having a particular kind of dominance driven by a very specific force.
Right. The report points squarely at the United States first, and it highlights that its leadership position is largely driven by its really robust private sector.
Yeah, you see those big names, don't you? IBM, Google, Microsoft are all in there, plus those sort of dynamic startups like Rigetti and IonQ. They seem to be the ones really pushing the envelope on the hardware and the software innovation side.
That's the core of their strategy, as the report describes it, this vibrant tech industry, the startup ecosystem. Now, there is significant federal support, too. You had the National Quantum Initiative Act back in 2018. That committed, over $3 billion to R&D. But the real engine, it suggests, is private enterprise and investment.
And that has led to some really high-profile moments, hasn't it? Google's claim of achieving quantum supremacy back in 2019. That felt like a major marker, even if, the term itself was pretty heavily debated at the time.
Oh, absolutely. It signaled something important, regardless of the semantics, that quantum computers were starting to do things classical ones just couldn't. And you see IBM continuing to show impressive scaling with their superconducting approach, like unveiling their Condor chip, 1,121 qubits, back in 2023. Now, getting that many qubits to work together perfectly is still a massive technical hurdle, but just the engineering feat itself is significant. Plus, you have spin-offs, like Sandbox AQ from Alphabet, exploring practical uses where AI meets quantum simulation.
Okay, so incredible innovation going on there. But the report also flags some significant challenges for this U.S. approach. What are those?
Well, the report highlights one key challenge, fragmentation. Because the innovation is so spread out across so many different private companies, universities, there's maybe less centralized national planning and coordination compared to what we see in some other countries. And that potentially could slow down really large-scale national projects or strategic alignment across the board.
Okay, that sounds like a very different picture then from the next major player the report gets into, China. Their approach is described quite differently, state-orchestrated.
Fundamentally different, yes. China's strategy is painted as very centralized. It's driven heavily and funded heavily by the government, and the goal seems to be crystal clear: rapid acceleration in this field.
And the funding numbers mentioned, they certainly reflect that ambition. The report notes China has allocated over $15 billion in government funds just for quantum research. That figure is really highlighted as the highest global commitment by far.
Yet that sheer scale of investment lets them build massive integrated national infrastructure. The report specifically calls out China's lead in quantum communication and cryptography. They've been building these extensive quantum networks on the ground.
And their milestones there are pretty undeniable, aren't they? That MISA satellite launched way back in 2016. That was a world first, wasn't it? Enabling that intercontinental quantum key distribution, QKD.
Yes, and that's hugely significant strategically. QKD uses quantum mechanics to basically guarantee unbreakable encryption keys. Sharing those securely over vast distances is vital for national security communications. The report also spotlights the team around Jian Pan, They're seen as global leaders in fundamental experiments, things like entanglement, teleportation, which are really foundational for both quantum computing and networking.
So clear strengths, especially in communication tech. What about the challenges? What does the report identify for China?
Well, while they're very strong in communication, the report does suggest China is still perhaps lagging a bit behind the U.S., specifically when it comes to developing general-purpose quantum computers, the really powerful, versatile machines. There are also challenges noted around maybe transparency and academic openness compared to Western nations, which can sometimes impact international collaboration and the free flow of knowledge.
All right, let's shift focus again. Moving to the European Union. Their strategy seems different again, leaning much more on collaboration across many countries.
That's right. The report characterizes the EU's approach as collaborative deep tech leadership. There's a recognition that individual member states, well, they need to work together to compete on that global scale.
And their funding reflects that collaborative model too, doesn't it? Especially through that big quantum flagship program. €1 billion over 10 years, I think.
Correct. And the report highlights that within the EU, different member states have their own specific strengths. Germany, France, the Netherlands, for instance, are noted for particular capabilities, especially in areas like advanced quantum sensors, photonic systems using light for quantum tech. These are crucial for precision measurement and building networks.
Are there specific EU milestones mentioned in the report that kind of stand out?
Yes, it points to companies like Pascal in France. They're developing quantum computers based on neutral atoms, which is one approach, and IQM over in Finland focusing on the superconducting qubits, more like IBM or Google. So this diversity of hardware approaches shows the breadth of the EU effort. And major research institutions like CERN and Delft are also highlighted for their work pushing forward scalable quantum network infrastructure across the continent.
Okay, so collaboration is the goal, it's baked into the strategy, but what are the main hurdles the report notes for the EU?
Well, despite programs like the flagship, the report suggests that fragmentation across the individual EU member states, that still remains a challenge. Ensuring cohesive strategy and execution across 27 different countries. Additionally, it notes the commercialization efforts actually turning that cutting-edge research into products and successful companies are maybe perceived as lagging a bit, lagging behind the faster pace perhaps seen in the U.S. and in China.
Right. So beyond these three major blocks, US, China, EU, the report also brings in several other important players, nations making significant contributions or focusing maybe on specific niches. Let's touch on the UK.
Okay, the UK. It's described as having a more agile and specialized approach. They launched their National Quantum Technologies program quite early on with investment over £1 billion.
And the report suggests they're targeting specific areas rather than trying to do everything.
Exactly. Their focus areas, according to this report, include things like quantum encryption, advanced sensing technologies, and also hybrid computing, trying to combine the best of classical and quantum systems. They've established key infrastructure, too, like the National Quantum Computing Center, the NQCC, to support R&D, and leading startups like Oxford Quantum Circuits and Quantinuum, which was a big merger, are highlighted as really driving things forward.
What about the challenges for the UK, based on the report's analysis?
Well, budgetary constraints compared to the really big economies are noted. That's perhaps obvious. And the report also raises the potential for disruption to, establish research partnerships with EU scientists following Brexit. That's mentioned as a factor.
Okay. India is also identified. An ambitious, emerging player is how the report puts it. What's their main focus?
India launched its national quantum mission fairly recently in 2023, but with a pretty substantial budget, around $730 million. And their emphasis, interestingly, much like China's noted strength, is heavily on quantum communication and cryptography, securing connectivity.
And they're looking towards space for this as well.
The report does mention plans by ISRO, India's space agency, for satellite-based quantum networks, sort of following in the footsteps of China's MISHA's project, yeah. They're also prioritizing building up the necessary talent pool, collaborating with major national institutions, the IITs, ISC, DRDO.
And where are their main challenges right now, according to the report?
It points to a still fairly nascent private sector ecosystem in quantum tech. And it highlights that their hardware development capabilities are still significantly behind the leading countries we've discussed.
Right. Finally, let's look briefly at Australia. What's their specialized contribution in this global picture?
Australia gets noted in the report for having really world-leading expertise in quantum material science. And the research that underpins a lot of this, particularly centered at institutions like UNSW in Sydney and the University of Sydney itself.
And they focused particularly heavily on one specific type of qubit technology.
Yes, they have significant research leadership in silicon-based qubit systems, trying to leverage existing semiconductor manufacturing know-how. The report highlights startups like Silicon Quantum Computing, which spun out of that UNSW research, and also QCTRL, which focuses more on the software side, improving quantum system performance and stability. A key technical milestone mentioned is their demonstration of world-first single-atom logic gates. Incredible precision at the atomic scale.
Australia is also involved in the quantum landscape through some important international partnerships too, right?
That's a crucial point, yeah. Their participation in the IoT Security Alliance with the US and UK explicitly includes a pillar focused on collaboration in advanced capabilities, including quantum technologies for defense. So it links their research strength directly to these major strategic alliances.
And the challenges outlined for Australia in the report.
Similar themes to some others' limitations due to a smaller national funding envelope compared to the giants, and also a relatively smaller domestic industrial base to really scale up these quantum technologies nationally. The report also does a nice job of providing a kind of comparative look across these countries, often using summary tables to try and rank perceived strengths in the different quantum domains: computing, communication, and sensing.
And looking at that comparison, it does become pretty clear. The U.S. is often presented as strongest overall, particularly leading in the computing aspect. China is presented as the, well, undisputed leader in communication technology. And the EU shows broad strength, but perhaps especially noted for sensing applications.
And when you see those funding figures laid out side by side, it's quite stark. China's reported $15 billion plus government commitment just dwarfs the others. The U.S. follows with its $3 billion plus federal commitment, though, as we said, the private sector funding there is likely much, much higher, but harder to pin down precisely. Then you have the EU's $1 billion plus for the flagship over a decade, the UK's $1 billion plus too. India and Australia's investments are significant for their size, certainly, but it just shows the difference in scale compared to the top players.
Yeah, it really paints a picture that's far bigger than just scientists and labs, doesn't it? The report dedicates a good section to these broader strategic implications of the whole quantum race.
And what's really fascinating here is how quickly this, quite advanced research translates into national power dynamics. National security is obviously a huge driver. You've got this tension. The race for quantum-resistant cryptography to protect sensitive data, while at the same time developing quantum computers that could potentially break current codes. That's a major security dynamic.
And the economic leverage feels massive, too. The report really emphasizes that getting a first-mover advantage in areas like quantum computing could genuinely reshape huge global industries. You think about finance, drug discovery, complex supply chain optimization. That's potentially trillions of dollars in economic value up for grabs.
Absolutely. And this definitely feeds into what you might call tech diplomacy. As the technology matures, countries are visibly forming alliances, specifically around quantum cooperation. We mentioned IOCISIS, the Quad grouping involving the US, Japan, India, Australia. Even bodies like the EU-US Trade and Technology Council are including quantum as a key area for collaboration. It's like they're choosing partners in this emerging technological landscape.
And running underneath all of this, there's that critical bottleneck the report keeps mentioning: the global talent war. Just the ability to find, train, and crucially keep the top quantum scientists, engineers, technicians, that's going to be absolutely fundamental in determining who can actually deliver on their strategy long term.
Yeah, which raises an important question sort of derived from the report's analysis beyond just, throwing money at the problem. Do countries have the educational pipeline set up, the industrial infrastructure needed to actually nurture and then utilize this highly specialized talent effectively? It's about much more than just the initial research. It's building that whole ecosystem.
So pulling back then and looking at the big picture painted by this 2025 report, the key takeaway feels pretty stark. This global quantum race is accelerating and accelerating dramatically, driven by competing national interests.
Yes, and importantly, as we've discussed, driven by very different strategic approaches. You've got the U.S. relying on the dynamism, maybe the chaos of its private sector, China relying on that centralized, state-orchestrated model, and the EU trying this cross-border collaborative approach.
And each of those strategies, as the report highlights, comes with its own distinct strengths, but also distinct challenges. Fragmentation potentially hindering coordination in the US and EU, while China might face hurdles in general-purpose computing, maybe transparency.
And we also see how other nations, despite perhaps smaller scale, are finding ways to compete or contribute by focusing on specific areas, the UK in those specialized niches, India prioritizing communication infrastructure, Australia leveraging its unique expertise in materials and silicon-based systems.
The report really makes it clear the stakes are incredibly high here. This isn't just confined to labs anymore. It's deeply intertwined with national security, with economic competition, with the formation of new global alliances, and that fundamental challenge of building the future quantum
What
workforce.
really highlights that the strategic decisions, the breakthroughs happening now, particularly it suggests in the next 5 years or so. These are what the report calls critical. Critical in shaping what it terms the emerging quantum world order.
It really does make you pause and think, doesn't it? Considering these very different national strategies we've pulled out from the report, the state-led versus the private-driven versus the collaborative models, and the varying technological focuses too, computing, communication, sensing. Which approach do you think, reflecting on this, is ultimately best positioned for long-term global leadership in this whole quantum race? And maybe more importantly, what might that actually mean for the balance of power in the world down the line?